Good morning, everyone. I'd like to first start out by saying hello and hope that you all are having a good day. The first thing that I want to talk about is how to calculate solubility equilibria for slightly soluble salts or insoluble salts. That is known as the KSP. As you can see from the picture that I am sharing with you, you're going to get a solid product when you mix potassium iodide, Ki, with lead 2 nitrate, PbNO3 taken twice. You're going to precipitate out PbI2. It is a yellowish type of precipitate. On the next slide, I have provided you with some KSP values taken from a textbook. It's not your textbook, it was another textbook. However, you will find your KSP values in the back of your appendix. I believe it's in Appendix A-4, I think. So here's a typical example of how you would solve a solubility product for equilibrium with a slightly soluble or insoluble salt. They're always going to give it to you at room temperature because all the KSP values are done at room temperature. And remember, as previously stated in other PowerPoints, the only thing that affects the K value is temperature. So you can see for silver iodide, the KSP is given as 1.5 times 10 to the negative 16th, so you can see hardly any of it will break up. But you do write your equation. You write your ions breaking up as your silver plus 1 aqueous plus the iodide minus aqueous. You build your ice chart. So in the beginning, you have no silver ion breaking apart and no iodide ion because it does take a while. You know that over time, some of it will break apart. You don't know what that is, so that sum is labeled as X. It is the solubility of silver iodide in concentration. And you know you're going to get some of the iodide ion in concentration. So at equilibrium, you add the I and the C together. So 0 plus X gives you X in both of those cases. Then you write your expression. So that is something that I did not do here. I just showed the end result. So my expression would be the KSP equals the concentration of silver plus, in brackets, times the concentration of iodine minus, in brackets. Then I would have 1.5 times 10 to the minus 16th, which is the KSP, equaling to X times X, which is X squared. I would then take the square root, and this would give me my concentration of my silver and my iodine at equilibrium. Here is another example, but this time I have lead 2 chloride. I've looked up the equilibrium solubility product constant for lead 2 chloride. It was on slide 2, or you can look it up in the back of your textbook. This is the KSP for the lead 2 chloride at room temperature. Once again, you have to make sure that you write your equation. All salts will break up into their respective ions. So the lead breaks up into the Pb plus 2 ion aqueous and 2 chloride ions. Make sure that you're not writing any diatomic gases. In the beginning, you have none of the ions. As the change, you're going to add some of the lead. So we let that unknown amount be plus X. And you'll have twice that amount of chloride, so plus 2X. At equilibrium, you simply add the I and C, so 0 plus X gives you X, 0 plus 2X gives you 2X. Once again, on this slide, I did not write the expression with the chemicals. You should do so. It should be here, KSP equals to the concentration of Pb plus 2 in brackets times the concentration of Cl minus squared because of the coefficient in brackets. So then I would put in what my KSP is. I'd put in the X, and then of course at equilibrium you have 2X squared. So 2X squared gives you 4x squared times x gives you 4x cubed. You divide both sides by 4, and you would need to use your button in your calculator that gives you the cube root, because you need to take the cube root of this, and you would then find out what x is, and then you could double that amount to place what 2x is for the chloride ion. Now, here is a classic example of how solubility will be affected when you add a common ion to the situation. So they have a salt that is silver iodide. We have looked up the KSP value, 1.5 times 10 to the minus 6. And now we're going to add the common ion of iodide from sodium iodide in. Remember, sodium is a spectator ion. It will not be involved in any situation. Only the iodine is the important piece. So when you go write your ice chart, you don't have any of the silver ion breaking up initially. However, you do have some of the iodide ion, and that is being contributed to from the sodium iodide. So I have 0.05 molar of iodide ion initially from the sodium iodide. I know that over time I'm going to add some silver, and I'm going to add some iodide ion to the initial. So that at equilibrium, I will have x from 0 plus x giving me x, and then I will have 0.05 plus x. And this middle piece should have just said plus x here. And then I have 0.05 plus x. There we go. And then at equilibrium, once again, I just showed the numbers. You needed to write what the expression is by itself. So you should have write KSP equals the concentration of silver in brackets times the concentration of iodide in brackets. Then underneath, I have the numbers. KSP value is 1.5 times 10 to the minus 6. I have x for silver and 0.05 plus x. Now, one of the things that you can always rely upon is that you will never have to use the quadratic equation in the AP. They always say that if the KSP has an exponent of 10 to the negative 4 or a smaller number, which means the exponent is going to be negative 5, negative 6, etc., then you can get rid of this plus x because it's so little that it is negligible. It's like saying you have $2 million and somebody steals a penny from you. It's not going to matter. So then I have 1.5 times 10 to the negative 16th equaling to x times 0.05. I divide 0.05 out of both sides, and then I have what my x is. And that x is the concentration of the silver, and this amount plus this is the concentration of iodide, so it's pretty much only going to be 0.05. Now, this next slide, we are not really dealing with at all because they have gotten rid of this particular information for a lab that used to be done. So I'm going to skip over this slide. I'm also going to skip over complex ions. They are not addressed anymore on the AP exam. So this slide is not addressed, nor is this slide. And the only thing that I want to talk about regarding this last piece of slide is if you have a solubility product constant from a slightly soluble salt and they're trying to generate another salt, it's like having a Hess's law problem. So they would give you each of the reactions, they'd give you the end result, and then they would ask you to find the overall K. So if they give you a bunch of Ks, your overall K is the multiplication of all of the Ks together. That's all you need to know. So hopefully this information was helpful to you. I will be uploading this into your Google Classroom. I hope that you all have a nice day.